Hello everyone, myself Prayat Patel, working as an assistant professor in IT ICT department of LJ Institute of Engineering and Technology. In today's video lecture, I will discuss about the insertion sort algorithm in sorting algorithms. So we already discussed the sum algorithm of sorting. Now in today's video lecture, I will discuss about the insertion sort algorithm. Now for understanding of insertion sort algorithm, consider one example, and using this example you can understand how insertion sort algorithm will work. Sort the following element in ascending order. So consider the element as a 5, 1, 12, minus 5, 16, 2, 12 and 40. And consider the arrangement of this element into the ascending order using the insertion sort algorithm. Now consider the step number 1. In step number 1, consider initially as an unsorted array. All the element consider as an unsorted list. Now you can sort the element one by one. In insertion sort, you can consider as a when we insert the any element, then sort this element. Means initially consider first element 5 will be inserted, then arrange 5 in proper place. Then 1 will be inserted, then consider arrangement of 1 and 5. Means first we put 1, then 5 like this. So this type of process will be executed for insertion sort algorithm. Now consider the step number 2. In step number 2, consider I equal to 2, because already we say that first value or only one value are there, then no need to arrange this value. So 5 is already sorted. So consider the I equal to 2 at your initial value, and consider the x element or x variable. X variable will be stored the value of the I element. So here consider x equal to 1. Now consider the condition j equal to I minus 1 and j greater than 0. This is a condition for your algorithm. So value of j equal to consider as a previous value of I. So I equal to 2. Then we can say that j equal to 1. So this location 1 consider as a j, and j greater than 0 means these two conditions will be satisfied. Then you can consider your algorithm or apply this algorithm. So consider this value, and now consider the x equal to 1. Now condition is while x less than t of j, do t of j plus 1 equal to t of j and j equal to j minus minus. So here j equal to j minus 1. So x means 1, t of j means location 1. So t of j equal to 5. So here consider x is less than t of j. Your x value or your current location 2 value equal to 1. So your value 1 is less than 5. That's why we can say that first we put 1, then we will put the 5. So your next sequence is like 1 5, not 5 1. So that's why we consider this location and swap the operation between first and second location. So swap the value of 1 and 2 location. So move the 5 value from location 1 to 2. Then put the value of x equal to 1 at location 1. So here consider swapping swift operation. So move the 5 from location 1 to 2 and put the value x equal to 1 at location 1. Now this is considered as your step number 1, and consider the first two element as a sorted element. Now consider the step number 3. In step number 3, initially we can consider first two location as a already sorted, because we perform the step 1 and 2. Now in step number 3, consider the value of I equal to 3, means consider your current location as location number 3. Now x equal to 12, because location 3 value equal to 12. So x equal to 12. Now consider the condition j equal to I minus 1 and j greater than 0. So j equal to here consider the value as a location 2, because your value of I equal to 3. So j equal to 2. Condition is same as it is, x less than t of j, then t of j plus 1 equal to t of j and j minus minus. So here consider the value of j equal to 2, location 2. Now consider value as a 5. Here 12 is less than 5? No. So that's why we can say that no any swap operation will be required, no shift will take place. Here consider the right shifting process for each and every step, but if the condition is not satisfied, then right shift operation will be not executed. So here consider no shift will be take place. Now consider the next step, step number 4. In step number 4, we already consider first 3 location as a sorted element. Now consider the value of I equal to 4 means location number 4 and value of the location 4 equal to minus 5. So x equal to minus 5. Condition is a j equal to I minus 1 and j greater than 0. So here consider j equal to your previous element of I. So j value consider as a location number 3. Now a t of j equal to 12 and x equal to minus 5 means we can say that x less than t of j condition is satisfied. That's why we perform the right shift operation, because t of j plus 1 equal to t of j means right shift operation. So here consider the 12 move from the location 3 to location 4. So here consider the 12 value at location 4. Now consider the previous element. So here consider the previous value because we perform the j minus minus operation. So here in previous case j equal to 3. Now consider the value of j equal to j minus minus. So consider value of j equal to 2. So j equal to 2. A of j means t of j equal to 5. So here consider x means minus 5. T of j means 5. So minus 5 is less than 5. Yes. Then right shift operation will be take place. So here consider this shift down operation means 5 move from the location 2 to the location 3. Now consider the decrement of j. So j equal to already j value equal to 2. Now decrement of j, then j consider as a location 1. X equal to minus 5, t of 1 equal to 1. So minus 5 is less than 1. Yes. Then right shift or shift down operation will be executed. So here consider shift down means 1 move from the location 1 to the location 2. Now consider the value of j, decrement of value of j. So already value of j equal to 1. Now j minus minus means j equal to 0. That's why we can say that j greater than 0 condition will be not satisfied. So we can put the value of x into the your desired location 1. So here consider value of x equal to minus 5 and put the minus 5 at location 1. Now consider the next step, step number 5. In step number 5, already your first 4 value is sorted. Now consider the I equal to 5 means location number 5, x equal to 16, value equal to 16. Same condition, same while loop. Now consider the value of j, j equal to 4 because I equal to 5, then j equal to 4. Now t of j equal to 12 and x equal to 16. So 12 is less than 16 means 16 is less than 12 condition is not satisfied. So no any right shift operation will be take place means consider no shift will take place. Now consider next step, step number 6. In step number 6 consider the first 5 value as a sorted list. Now consider the next location as a I equal to 6 means x equal to 2, value equal to 2. J equal to I minus 1 and j greater than 0 and also consider the while loop. Now what is the value of j? Value of j equal to 5. So if t of j equal to 16, then consider the value 16 at your location number 5. Now consider the value of x. X is less than 16. Yes, means here consider 16 and value as a 2. So right shift operation of the shift down operation of the 16 value. So put the 16 from location 5 to 6 and consider the value of j as a 4 because decrement of j. So j equal to 4. Now consider the value as a 12. So 12 is less than 2. Here consider the x as a 2 and 12 as a t of j. So 2 is less than 12. Yes. Then right shift operation of the 12 or shift down operation for the 12. So 12 move from the location 4 to 5. Now consider the value of j as a 3. So t of j equal to 5. So 2 less than 5 condition is satisfied. Yes. Then move the 5 from location 3 to 4. Means shift down operation from 3 to 4. Now consider the next value of j. Next value of j consider as a 2. And in this case consider the t of j equal to 1 and x equal to 2. So 2 less than 1 condition is not satisfied. That's why we can say that put the value of x at your location number 3. So put the 2 at location number 3. Now same process will be repeated. Now consider the next step. In next step, step number 7, consider the first 6 element as a sorted. Now your next location as a location number 7, I equal to 7 and x equal to 12. J equal to I minus 1 and while loop. Now consider the value of j as a 6 because previous element of the I. So j equal to 6. Now consider the 16 as a t of j and x as a 12. So 12 is less than 16. Yes. Then right shift or shift down operation between the 6 and 7 location. So 16 value move from the location 6 to location 7. So here consider the value 16 put at the location 7. Now consider the previous value of j. So here consider the previous location of the j as a location number 5, value equal to 12. So x equal to 12 and t of j also 12. So 12 equal to 12, 12 less than 12 condition is not satisfied because here only condition is less than, not equal. So 12 less than 12 condition is false. That's why not shifting down operation will be performed. Directly we put the value of x at location number 6. So here consider the value 12 at location number 6. Now consider the next step as a step number 8. In step number 8, already 7 elements are sorted. Now consider the location 8 value equal to 40. So I equal to 8, x equal to 40. Now j equal to 7 because I equal to 8, then j equal to 7. So j equal to 7, then t of j equal to 16. So x less than t of j means here consider 14 is less than 16. Yes. Then shift down operation will be performed. Means 16 move from the location 7 to location 8. So here consider the movement of the 16 from 7 to 8. Now consider the previous element of the j means here consider the 6th location. Now value is 12, t of j equal to 12 and x equal to 14. So 14 is less than 12 condition is not satisfied. That's why we can say that no shift down operation will be performed. So here consider put the value of x at location number 7. So this is considered as a final list of the insertion sort. After performing the step number 8, you will get the sorted list as a -5, 1, 2, 5, 12, 12, 14 and 16. So this is your final answer. Now consider the algorithm of the insertion sort. Now first input consider as a array A or array T. In this case we consider the array T. So T consider as your input array. What is the output? Output required as a sorted array T. Now algorithm, name of the algorithm as a insertion sort. T1 to n means array T location 1 to n will be considered as a one array T. Now first loop is for I equal to 2 to n do. Why we start the loop of I from location 2? Because already if the one element in an array, then no need to arrange this element or sort this element. So your process will be start from the location 2. So for I equal to 2 to n, you can perform the operation. Now consider the first as a x equal to t of I. T of I means value of t of 2 consider as a x. Initially your current location is 2, then t of 2 consider as a x. J equal to I minus 1. What is the initial value of j? Previous location of I. So we can say that j equal to I minus 1. While x less than t of j and j greater than 0 do means this is your condition for shift down operation. So x less than t of j means your previous location or current value of the x and previous value match these two elements. If x is less than t of j, then perform the following operation. Now what is the operation? Operation is t of j plus 1 equal to t of j means right shift operation of your particular data. Then j equal to j minus 1 means consider the decrement operation of the j. Then after performing this operation, consider t of j plus 1 equal to x means because we decrement the j, after swapping operation or shift down operation will be stopped. Then consider the value of x or put the value of x at the your location t of j plus 1. Now this is considered as an algorithm. Now consider the insertion sort analysis part. Now in analysis part, what is the time complexity of insertion sort? Here consider the two loop. First loop is I from 2 to n, do following green shaded line. So here consider this loop as a I from 2 to n. So this loop will be executed for n time. That's why we can say that the complexity for this loop is theta of n. Now consider the inner loop as a while loop. In this while loop, consider the x less than t of j and j greater than 0. Then do these two operations will be performed in the inner loop of the while loop. So this loop will be executed for n square time. So complexity of this loop consider as a n square. So overall we can say that the complexity of the insertion sort algorithm is theta of n square. So consider this is your complexity. Now consider the best case of the insertion sort. So best case for the sorting algorithm for the insertion sort, we can say that the given list is already sorted list, means already ascending data are given. Then you can say that this loop or this array is already sorted array. That's why we can say that the best case of the insertion sort. So here consider one example of insertion sort best case. So given data is 12, 23, 34, 45 and 59, already sorted list. Now consider the first process, pass number 1. In pass number 1 you perform I equal to 2 to n operation. So here consider initially I equal to 2, then t of j. What is the value of t of j? If I equal to 2, then j equal to 1. So t of 1 and t of 1 value equal to 12. So here consider x less than t of j. So here consider x is 23 and t of j equal to 12. So no any shift down operation will be performed. Then consider I equal to 3. For I equal to 3, t of j equal to 23. So here also condition will not satisfy. Next consider I equal to 4. For I equal to 4, consider t of j equal to 34 and x equal to 45. So 45 less than 34 condition will not satisfy. So consider the next value of I, and next value of I equal to 5, because here n equal to 5. So last value of I equal to 5. Now t of j equal to 45 because j equal to 4 and I equal to 5. So t of j equal to 45 and x equal to 59. So 59 less than 45 condition will not satisfy. That's why we can say that no any shift operation will be executed. So in this while loop, no single time you can move into the while loop and swap the location t of j plus 1 to t of j and j equal to j minus 1. These two statements will not executed for single time. So that's why we can say that this while loop will be executed as a normal statement of the outer for loop I from 2 to n. That's why we can say that this loop will be executed for n time only, not inner loop will be executed repeatedly for n square time. So we can say that the complexity of the best case or best case complexity of insertion sort equal to theta of n. So this is considered as a best case complexity. Now consider the another example for the insertion sort and arrange this data into the descending order using the insertion sort algorithm. In this case, you can consider the reverse condition of your algorithm. Now sort the given data 3, 9, 6, 5, 23 and 14 into the descending order. Now step number 1. In step number 1, given data is like 3, 9, 6, 5, 23 and 14. So initially consider the same value. Now step number 2. In step number 2, we can start the process from location number 2 because already in step number 1, 3 value is already sorted. Now in second step, consider the value 3 and 9. So in descending order, first we put 9, then 3. So that's why we can say that swapping of this first two element. So after the step number 2, your value is 9, 3, then 6, 5, 23 and 40. Now consider the step number 3. In step number 3, first value consider as a 9, then consider as a next value as a 3 and third value as a 6. Now insert the 6. Because in step number 1 you insert the 3, then step number 2 you insert the 9, then step number 3 you insert the 6. So if we insert the 6, then descending order like 9, 6 and 3. That's why we can say that right shifting of the element 3 and put the value 6 at second location. So shifted after shifting, consider resultant as a 9, 6 and 3. Now step number 4. In step number 4, next value consider as a 5. So put the 5 in descending order. So we can say that 9, 6, 5 and 3. That's why we consider right shifting operation of 3. Then put the 5 at remaining location number 3. Now consider the step number 4. In step number 5, already 4 elements are sorted. Now consider the value as a 23. So put the 23 at first position. That's why we can say that right shifting of each and every element. So here first right shift of 3, then right shift of 5, then right shift of 6, then 9, then put the 23 at first location. Now consider the 14. Now for that consider the step number 6. Now 14 is put after the 23. That's why we can say that right shifting of 3, 5, 6 and 9 will be performed. Then put the 14 at the second location. So right shifting of this and put the 14 at location number 2. So this is a simple example of the insertion sort algorithm. Now in today's video lecture, I will discuss about the how insertion sort algorithm will work using one example, and also we consider the analysis part of the insertion sort algorithm. Remaining sorting algorithm will be discussed in our next video lecture. Thank you for watching.